at the University of Utah. And for this example, I wanted to go over complex impedances. So the goal is to calculate complex impedances when we have a circuit such as this. So to do this, we need to first transform it from the time domain into the frequency domain. So for an inductor, you're going to use the j omega L, and omega is given in this case as 1K. So you just multiply the 1K times the 10 milli to get 10J. For each of the capacitors, these are all the same value, so we can calculate them all at once. It's going to be a minus J over omega C or 1 over J omega C. So you plug in the 1K for omega, and C in this case is 500 micro. And this gives a value of a minus 10J. So for every capacitor in there, you're going to use minus 10J, and for every inductor, you're going to use a plus 10J. So these are all minus 10J. So we no longer use the millihenries or the microfarads. We're going to use the minus 10J for each of these components. From there, we need to look at what is in series and parallel, because now everything is in ohms. So these are all in ohms. So now we can treat them as resistors and combine them accordingly. So we notice that these two are in series, and that if we want to highlight these nodes, we will notice also that we have the C4 is in parallel with those two that are in series. And then they can be combined with C3 in series. And then all of that is in parallel with the 10J. So writing that out, we have our complex impedance Zn is equal to the C10, which is a minus 10J, and that's added to the 2K. Those were in series. That was in parallel with the C4, which was minus 10J, and that was all added to the C3, which was a minus 10J, and all of those were in parallel with the positive 10J. So this is how we would write that complex impedance. I would suggest using MATLAB to be able to calculate the rest of those. Remember, for anything that's in parallel, it's 1 over the quantity. And so x in parallel with y is equal to the 1 over x plus 1 over y. So we would need to plug that in for everything in parallel. And then this concludes this example. Thank you for watching.